also easier for everybody to access, right? Yeah. So I'll drop that page. You guys go subscribe. It's weird. It's like Apollo. Oh, whatever. Okay, you guys go with the parallelogram? No? Get the picture down too. Okay. Reason why I want you guys to have this down is because you know it, right? When a problem tells you something is a parallelogram, this stuff comes in automatically. Okay? Even if they don't draw you a parallelogram, right? Just by them saying, oh, this is a parallelogram, the opposite sides have to be parallel. Okay? Automatically, or else it's not a parallelogram, right? Alright. Even if they draw you a parallelogram with no arrows, you should know that these arrows are there because it's a parallelogram. It's in the name itself. Okay? And that's it for this one. Huh? What's the gram?
The O-gram.
The O-gram. It's for the quadrilateral part. Yeah, just think of it as like a gram, like a card. No? Okay. Okay, do you guys have any questions about this? Alright, so just in case, if the arrows aren't there, you should know that they are there.
How come it can't be in my circle?
What kind of questions are these? Okay, this theorem, this one, I don't want you to write it down.
What? Bro.
Okay, so go look at your theorem sheet. It should be on the second page, so just turn it over.
So I don't copy the.
No.
Okay.
I'll tell you what to copy down and where to copy it.
Why are you laughing at the kid?
Okay? Because I said don't copy. Ignore it, okay? Alright, so if you look at this, it's in the name. Okay, in the parallelogram, the opposite sides are going to be congruent. Okay? As long as you know what the opposite sides are.
You're trying so the diagram to match.
What?
Okay. It's different.
Doesn't matter. Okay, so you see here, my congruent sides, they are correlating, right? So whatever is an opposite side, as long as it is a parallelogram, they are congruent. Okay? So on your theorem sheet, like I know it's written in here, right? But trust me, I know people overlook this little wall of text.
Yeah.
So write it on the side right here where my finger is. Okay? What we're gonna write, we're just gonna write the pairs that are congruent. Okay? Okay. So QR should be congruent to PS. And what's the other one? QP and RS. Okay. If you have a parallelogram, this should also be automatic. Right there, congruent to each other. Okay. And then what do you guys think? If we deal with opposite sides, what else are we probably going to deal with? Opposite angles. Okay, but that's for the next theorem. Before we get to that theorem, I have one little thing that I want to show you guys. It'll help with proofs. Are you guys ready? Okay, this next part is going to go in your notebook. Okay, so here's a little section for congruence. Just wanted to talk about. See it in your test and everything. I have to give that to you, right? It's the same letters. Okay, we good?
No.
Yeah? No? Alright. Okay, so right here, you see that this parallelogram is being cut in half, or is it? Right, this is called a diagonal, okay? So far, you guys know that opposite sides of a parallelogram are congruent? So, what? What'd you say? Okay, so you got those markings there. The two sides are congruent, right? Okay, and if you have the diagonal that goes through almost the middle, is what you perceive, right? Huh? Okay, this is just a diagonal. But if you look at triangles, it's, remember some things about triangles. Did we prove that triangles, did we prove some triangles were congruent to each other?
Yeah.
Are you able to prove that these two triangles are congruent to each other? Yeah?
Alright, brush it up.
Reflexive. Reflexive, okay? So, the thing that we said for you guys to try to remember reflexive property was to say reflective, right? Because this line, IG, is the same as itself. Yeah? Well, yeah, it should be because it's itself, right? So then that means you have the two triangles are congruent by what? Huh? Nope. Triangles, 3 letters.
Oh, good.
All that.
What 3 do we have? SSS,
Oh,
right? Side. Okay, so those two triangles are congruent to each other. Yeah? So that's how we use a parallelogram and its diagonal to prove triangles congruence. Okay? I am not gonna talk about this one because
it's the same thing.
the diagonal is going the other way. It's the same thing. Okay? So this one is the same thing, right? I just want you guys to copy this down, just to have.
Why do you
Wait, you don't want me to give it to you?
no.
I mean, I could have just like left it for you guys to figure it out.
But,
Aren't I a teacher? Should I be doing my job?
Should ask.
I mean, like, why you give the same thing again? That's what I'm saying.
What do you mean? What same thing?
Same
So
thing.
you got the diagram.
You're telling me it's the same thing? It goes the other direction.
That answer is the same, isn't it?
Yeah,
Yeah,
but the
so-
pictures are different.
Bruh.
So what's your argument here? Nothing. Don't try to argue with me. 90% of the time, I'll prove you wrong. You have 10% chance. At least try. What the? Good? No? And then this next part, we're just gonna look and write it down on the theorem sheet, okay? Good? Okay, so on your theorem sheet, go to 7.4. We're gonna talk about that one now. Okay, so like I just said, we talked about opposite sides. So now we're gonna talk about opposite angles. And the same thing happens here. So opposite angles should be what? Congruent. Okay, so let's just write them. So I don't know, you guys tell me. What's the first one you want to write? So angle
What angle
Q. Oh, I heard Q first. So Q is
Angle S
angle S, and then R
and P.
and P. Okay, so those two theorems, I guess they're like the basics for parallelograms, right? They'll always be there. You always think about them when you deal with your problems, like math problems. Okay, you guys have this on the sheet already? Yeah. Okay. It's gonna lead us to the first example. This one, of course, goes in your notebook. So write it down first. Should I like spice things up?
No.
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 Use a note card? No, I was like gonna spice it up by doing this. So I'll change this
What? Why?
because it's too easy. Even then, I think it's still, you know. There, I made it a little bit more difficult.
Right.
You think I should use the cards? This stuff, you guys definitely could use. Oh look, you're still here. Huh? I kept their car. Huh? Who's this? Oh, Kevin.
What?
You drew this. I was like, curious, so I just picked it.
Oh,
Yeah.
Cool.
Alright, so Kevin, which one do you want to solve for first? Bless
What?
you. Which one do you want to solve for first?
DI.
What? Oh, DI? So for X? Okay. So can you tell me what theorem that you want to use? Two. We start with 3.
Okay. Let's start with 3 then.
Alright, fine. Theorem 7.3 says opposite what are congruent?
Yeah. Why you asking?
What is DI? Is DI a side or an angle?
That's side.
A side, so opposite sides are congruent, yeah?
GA.
GA. Okay, choose someone.
Me?
Yeah, you.
Someone?
Choose someone.
David?
David? What am I gonna set my equation as? David? How am I gonna set up my equation to solve this? Hmm? So I have this right here. So DI is congruent to GA. You can set up an equation, right? Someone want to help him out? X plus 4 is equal to 12. Okay? This one you just subtract by 4, and X is equal to 8. So that one's done. Okay. Right there.
Oh.
Can you help me out for Y? Yep. Theorem 7.4 says what? Good. So angle D is congruent to angle A. Okay, pick someone. Set up the equation.
It is 5y equals 65.
Okay, thank you. And then what do we do to both sides to find y? Divide. So divide by 5, and y should be what? 13.
What? Oh,
What?
never.
Okay. Okay. So, it's not too crazy, right? Okay. So you just gotta figure out which ones you're gonna set equal to each other, and then solve. Simple algebra, right? Okay. Do you guys have any questions right now? We're good? Okay. So next.
Do you have any problem with that?
No. This one's in your theorem sheet, so look at 7.5 in your theorems. Okay, so let me try to remind you guys. You guys remember when we dealt with parallel lines?
Yeah.
Do you remember all the theorems?
No.
There's 4 of them. Alternate interior, alternate exterior,
And the line is linear? No, linear.
something interior, it starts with a C. Consecutive.
Consecutive interior, consecutive exterior.
The words right there, right? consecutive interior angles. Do you guys remember what happens with the consecutive interior angles?
No.
They what?
They go boom.
They go boom. What? They add up to equal 180. Okay? So the same idea is right here. But like when you deal with parallelograms, aren't you dealing with parallel lines? Yeah? So all those alternate interior stuff comes back. Actually the alternate interior stuff was this theorem right here. Okay? That's alternate interior. Okay? So right here, consecutive. So then can you guys help me out? If we know that consecutive angles add up to 180. So let's start with what? Angle Q plus angle R equals 180. Okay, I'll just go with cards. Jeremy? Look. See what we put? Do you know which 2 consecutive angles gives me 180? I already did one of them, is Q and R. Can you give me another one? Yeah. RQ, yes, it's just the other way, right? But let's use R. Plus another one. S equals 180. Okay, Jeremy, pick someone. Alright, Eli, what's next?
I don't know.
Oh well. Is that a good you wanna think about it a little bit?
Huh?
Choose one of the angles that we haven't touched yet.
P.
P, okay. So what are you gonna add to angle P to give 180?
S.
S. Okay, equals 180. Okay. Eli, choose someone else.
Emmanuel.
Alright, what's the last one? P and Q, yes. Okay, this stuff isn't too crazy, people. You just choose a pair and keep going. Okay. So these two. Okay? Do you guys have any questions for this? We're okay? Hope so. Okay. Last one. Okay, I think this one is could be the most confusing and the most important one. No.
Okay.
This one will still go in the theorem sheet, right? Okay. Talking about. Oh. Okay. So we're gonna go here. Okay. This one is dealing with the diagonals. Okay. And I say that this is probably the most confusing because people will get it wrong all the time. Alright? So you guys agree with me that each one is a diagonal, right?
Yeah.
Okay? Do you think that this diagonal QS is equal to our piece?
Yeah. Oh wait, no. The M is midpoint, so it's
That's what you want to believe, right?
good.
Okay? But it's only true when you have like a square or around this. Okay?
So I have the right.
Huh?
No.
No. So I'm telling you right now, please don't try to set the two diagonals equal to each other for parallelograms.
So it's like it's Q and then M or Q and then R, MS and
You did say something mostly correct with the midpoint, okay? But basically, whenever you have a parallelogram and you have two diagonals crossing each other, they bisect each other. Okay, do you guys remember what bisecting means? Cut in half, split in half, cut through the middle. Okay, so that means QM and MS are congruent. And what else? PM and MR. Okay, great. So those are the first two things I'm gonna write down. Okay. QM is congruent to MS, and then PM congruent to MR. And then the 3 and 4 are not congruent. That I just wanted to let you know. Okay? I know it's some people might look at it and say, oh, isn't that obvious? Because they have different markings. Right? But I want to say, like, for one of the cases, MR is not congruent to MS. Okay? They have different markings, right?
QR and PS and P and R.
So MR not congruent to MS. And then 4, I put a star because it was like the most important one. I did talk about it towards the beginning. Okay, it's QS not congruent to PR. Okay, that number 4, that one gets everyone all the time. Okay, me included when I was learning it. Okay, so be careful. No, I have one example.
I know, but like what?
Oh yeah, that's it for the theorem sheet. Okay. Okay. So this last example, goes into your notebook. After that, we're done. What? I said I had 2 examples, no? Yeah, this is the second one. 2. And I think when I said last one, I meant last theorem. What?
So this is the same.
Yeah. Okay, so this example focuses on the last 2 theorems we did, right? Now use the cards again. Hmm?
What's the number then?
For D, that's 110. It says right there too. Okay. I just have one comment because I still see people making this mistake, right? So, whenever you deal with angles, and it could just be because you're not listening. Because I noticed some people tapping out, right? For when you refer to an angle, how many letters? Three or one. Okay, one when it's like obviously in a corner by itself, right? Okay, but over here, can I just use one?
No, it's three.
Yeah, no, because there's two little angles right here. Okay, so there's always three.
Yeah.
It's three regardless. One when there's only one angle that you see. Okay, so when you guys see the three letters, I don't think of any reason why we are confused. But when I tell you guys, right, you read the three letters A, D, C. You take your finger physically, you put your finger on there. A, D, C. That thing you just drew is an angle. Okay. Usually the angle is referring to the letter in the middle. Okay. So that means this angle right here. This is all 110. Okay. That's the first part. So if we're trying to find this angle ABCD, do you guys know what theorem I should be using? 7.5. Okay, 7.5 is the one with consecutive angles, right? And consecutive angles you have to add up to get 180. So if that side right there is 110, 8 BCD should be 70. Okay, this is what the setup looks like. So I'll say by theorem 7.6 5 measure angle ADC plus measure angle BCD is equal to 180. Okay, you already know ADC is 110, so you plug it in. Okay, subtract the 110, and you should end up with 70, right? Okay, that's it for that one. For the other part, right? 7.6, because we're dealing with what? That line has a name, starts with a D, diagonal. Okay? So, due to that theorem, what are you going to do with AM and MC? Set them equal to each other, or make them congruent. So AM congruent to MC. Okay, and that means x plus 4 is equal to 16. And x is equal to 12, right? Okay, so like I said at the beginning of geometry, right? You're going to take your theorems, apply them, then it's a basic algebra problem. Okay? You just got to know the theorem. Huh?
Is it all?
Yeah. Okay, are you guys okay? Yeah? Alright, so here's the homework. Okay, but I also gotta tell you something about the homework. Okay, eventually when you guys get to problem 9, they're gonna give you this picture. Okay, pay attention, cause you're gonna ask me the same question if you don't.
I will,
Okay.
can I
So
ask
you-
for everything?
No.
Why?
You see this 100 degrees? They draw it just like this, and the arrow is pointing to this little angle, right? Okay, but it's not just for this little angle right here. It's for the entire thing, or what you would call angle L. Make sense? Okay. Okay. And that's it.